All right, we're going to start today reminding ourselves how to solve a system of equations by graphing. So in number one, we have these two equations, two linear equations. There's going to be two lines. We're going to graph them and see where they intersect. So these are in slope-intercept form. So we can use that information to graph this. So remember, we start here at the y-intercept. So we're going to come down on our y-axis and put a point there at -1. And then we're going to count our slope, which is the -1/2. So from our y-intercept, we're going to go down 1 over 2, down 1 over 2, like this. You can go the other direction if you want. And hopefully, you can draw a nice, neat line there. No, I got a little sloppy there. Okay, we're going to do the same thing on the other one. This one has a y-intercept of -4. It is, and it has a slope of +1, 4. So we're going to go up 1 over 4, up 1 over 4. Nope, that was 3 right there. That's the point I wanted. I'll go ahead and draw that because we can see where they intersect. Wow, I totally missed that point, but it's supposed to be right here. Okay. So our solution to this is going to be, what does that look like? 4, -3. Now, you can already see the disadvantage to graphing these by hand, so you have to be really neat. I clearly was not. Okay, but this is our solution, okay? The point 4, -3 works in both of these equations. Let's check out the next one. First, we have the function y equals -1. Remember, when you have just y equals a number, that's going to be a horizontal line. If you had a function like x equals -1, that would be a vertical line. We don't have one of those right now, so we have a horizontal line. So we're going to go to -1 on the y-axis. We're going to attempt to make a horizontal line there. Hey, that's a lot better. All right, now my second function, it's not in slope-intercept form, and it's a little bit easier to graph if it is. So we're going to solve this for y. So we're going to start by subtracting 5x from both sides. So we get 2y equals -5x plus 8. And then we're going to divide everything by 2. So we get y equals, now this -5 divided by 2, you want to leave that as a fraction, -5 over 2, because that's going to be our rise over run, plus 4. Oh, we forgot the x. There we go. All right, so we are going to go to 4 on the axis, the y-axis here, and then we're going to count down 5. 1, 2, 3, 4, 5, and over 2, right there. That's my point. Okay, and you can do it again, down 5 over 2, but you get the idea. So here is that second line. Oh my word, that was the worst thing ever. Just try that again. There we go. And we are looking for the point of intersection, which we can see is right here. Looks like it's going to be 2, -1. So you've done that a ton. You did in Algebra 1, you probably did in Geometry. So this should look really familiar. Now, it could happen that you get parallel lines. You go to graph them, and they don't cross anywhere. They're parallel. We say that that has no solution. You could also end up graphing these, and they could end up right on top of each other. Basically, they're the same line, and we call that infinitely many solutions, which is a long word to write, infinitely many solutions. Most of the time, they're going to cross just at one point, but those are kind of the two strange cases we might wind up with. In the next video, we'll see how we can do this with equations that are not linear.